And our first presenter is Dr. Lisa Benson from Clemson.
Okay, thanks for coming, everybody. It feels really goofy, I have to tell you, to be in a room that seats 500 and anyway, but here we are. So the session is focused on outreach, on assessing and developing outreach activities in biomaterials, and the subtitle to my talk is actually a play on the theme for this meeting. As we pioneer the future of biomaterials, I would say what we should be focusing on is the people who are doing the pioneering. So we are actually pioneering those future biomaterials scientists and engineers. So a little bit about me, not because I want to talk about me, but I want to tell you a little bit about how I got here and why I'm talking to you right now, aside from the fact that Casper and Julie invited me, and thank you very much. So I'm actually a bioengineer that's how I identify. I have degrees in bioengineering from the University of Vermont and from Clemson University. I did my research on polymer wear and knee implants many millennia ago. And as I learned more about biomaterials and started to get really excited about what I was doing, I really wanted to share that with other people, and so I was naturally drawn to doing outreach activities. And I developed a summer camp and weekend programs and Girl Scout programs and that kind of thing. But was never really sure that what I was doing was right. Was it working? Is it the right way to do this? Is there a better way? I felt like I was throwing spaghetti at the wall, and sometimes it sticks and it's done, and sometimes it doesn't. So I figured there was a better way, and so I started to look at the literature in education, and there's this wealth of information about education research, about how people learn and the best way to help them to develop their identities as researchers and scientists and engineers. And the more I dug into that research, the more I was drawn to it, and that's my day job. I do education research, and I have joined a Department of Engineering and Science Education at Clemson, which was established about 8 years ago. And we're a cross-disciplinary department. We have science education researchers and engineering education researchers all working together. All of us have degrees in science or engineering, so we come at it from a disciplinary basis. We know very well what the challenges are for pushing our disciplines forward, for creating the future of biomaterials, for example. It takes a really solid understanding of what is involved with biomaterials research and education to know how to promote it and push it forward. So that's who I am, and I just wanted to, again, talk a little bit about that journey from throwing spaghetti at the wall to actually doing outreach activities in a very intentional and systematic way, in a way that they can be developed and assessed. So most of us here probably are doing outreach at some level or are interested in it, and we do lots of different programs, and sometimes they go according to plan and sometimes they don't. So I'd say the focus of what I want to talk to you about is this idea of outreach by design, doing this systematically, identifying objectives that you want to reach with your activity, and then identifying ways to assess if those objectives are being met. So why are we doing biomaterials outreach? For those of us at large land-grant institutions, this is part of who we are. This is part of the land-grant mission, right? Part of community partnership and public service. But even those at private institutions or in industry, this is really, community engagement is really important. In industry, you need future workers, so you should be involved in outreach as well. We want to disseminate what we learn to a non-technical audience. We want our knowledge to go beyond our lab walls. Stop me when this sounds familiar. Doesn't this look like broader impacts? If you've got a funded research project from the National Science Foundation, this is something that your funding agencies want you to do. And then, of course, my theme of building research infrastructure by looking at future biomaterials scientists and engineers. And I think it's kind of interesting that the logo for this year's meeting is this sort of android-looking anonymous type person. But really, the people that we're working with are real. These people are the future of biomaterials. So, how do we do outreach? What's the nature of what we do? Again, using the analogy of throwing spaghetti at the wall, often we gather up a pile of implants or sample materials in a bag, and we go to a high school, we put some PowerPoint presentations together, maybe we've got some hands-on activities that we can do with them. But a lot of what we tend to do tends to be sort of that, what we're calling a favorite uncle model. So picture yourself, a little kid, maybe sitting at home during the summer in a house, and you're kind of bored, and along comes your favorite uncle visiting for the day, and he picks you up and he takes you to the fair, and you get ice cream and popcorn, and you ride the Ferris wheel and bumper cars, and you do all kinds of fun stuff, and then he drops you back off at home, and you're back in your house, and you're still bored, and everything is the same. Nothing has changed about your path forward. And so lots of our outreach programs tend to be that way. They're kind of a one and done kind of thing. So what I would encourage you to do is to think about this systematically and think about what it is that students tend to remember. And learning science and education psychologists have a lot to tell us about what people remember based on what they're doing. So students tend to remember very little of what they read, hear, and see, but they tend to remember a lot of what they say and do. So that's what we want to have, that's what we want to do with them. We want to kind of move past the demonstrations and show and tell type things to really having them, simulating what a scientist or an engineer would do, moving them from that passive model of involvement to a very active involvement. So how do you plan something like that? I would say the best way to do it is to approach it the way you would approach a research project. You would probably not be taking a biomaterial that you thought was a cool material and sticking it in a bunny rabbit because you thought it might work. You might need some evidence before you get to that step, right? So you need to think systematically about a research project, and in the same way you need to think systematically about outreach activities. So if you're planning a research project, you might think about funding agencies, what they're looking at, choose your objectives based on those and on your own expertise, and then choose the scope and the content based on what kind of resources you have available. And likewise, with an outreach activity, you want to determine the background and the interests of the participants that are going to be in your outreach. You'll choose objectives based on those backgrounds and also based on your expertise and interest. And then you choose the scope and content based on the resources that you have available. Very similar steps in planning. With a research project, you're going to develop a research plan. You're going to have some kind of theory you're going to base it on. You're going to design experiments, methods, ways to analyze your data and interpret it. You're going to develop ways to evaluate if your project was successful, ways to disseminate what you're finding. And then you're going to prepare your proposal after you've put all that thought into it. Well, in a similar way, you're going to develop learning activities that achieve the outcomes you want to achieve with your outreach project. Maybe you'll develop some background information, you'll design some activities, but those will be backed up by maybe handouts for students or teachers or even parents. Then you need to develop some assessments to see if your objectives are being met. Are your students learning? Are you changing their minds about anything? Are you altering their attitudes or their beliefs, maybe even their career goals? Then you plan then you put your research, your outreach program together. I would like to point out that I've mentioned teachers a few times in here, and think about including them as participants in your outreach, partnering with them or including them in your programs, because this is our little pyramid scheme where if we involve teachers, teachers then involve hundreds and thousands of other students, and they know how to teach them much better than we do. So these are some teachers who are participating in an outreach project that I did, and they're great participants. They're so eager to learn. Okay, so how do you actually design an outreach activity or develop it? I would consider using the logic model approach, and many of us who are doing research proposals to get funding follow logic models to try to structure what we're doing and to match some kind of evaluation plan with that. So there are steps to that, right? This is logic. If I do certain things, then there is going to be some certain outcome. So plan your outreach program with a logic model, starting with anticipated outcomes. What is it that you think the students or participants are going to get out of this? Connect your activities to those outcomes, and then identify what kind of resources you need to make that happen. And then use that logic model to develop your assessments. Plan ahead for when you're going to collect data, understand who your audience is. Are they little kids that maybe don't know how to read and write yet, or are they teachers who can actually give you some really in-depth reflections on what they're thinking? And then plan ways to track the progress of your project. And then lastly, developing that assessment plan means you need to have some kind of quantifiable evidence, some kind of indicators that are going to show that what you're doing is actually working. Choosing, time frame, writing objectives, and carrying out some kind of plan. So this actually came from a website called the Outreach Evaluation Resource Center, and I found some really valuable resources there, and I put the link there. And I think are these slides going to be available to the participants, or can I post these slides somewhere? Yeah, we can make these slides available because there's lots of links and stuff in here. Anyway, so anybody who's used a logic model, this might look familiar. You identify your inputs, what kind of things you're going to invest, staff, time, money, research infrastructure, maybe technology, and then you identify what you're going to do. Maybe it's going to be a workshop or a camp, maybe it's going to be some kind of online information, and who your target audience is, who you're going to reach. And then from that, if those things are done, then this is what's going to happen. We're going to have some short-term results. Maybe we're going to help our students to learn something. Maybe we're going to change their attitudes, help them develop some career goals. Maybe we're actually going to change teachers' practices. Maybe they're going to include engineering or biomaterials research in their science classrooms. Maybe our students are going to make some decisions about where they're going to go in the future. And then long term, we're talking about changing educational environments. We're talking about changing social environments in terms of after school or out of school programs. So really big long-term outcomes. So as you can see, the outcomes of outreach programs can relate in some cases more to students' attitudes than they do to their content knowledge. You'll see lots of reports about outreach activities that are often inconclusive. Some students learned better, some students tested better at the end of the year, and some students didn't. It's kind of a wash. It's sort of a Hippocratic approach. Like, we didn't do any harm. I don't think we brain damaged students who participated, but maybe we didn't really affect their learning very much. But I think maybe we're measuring the wrong thing. Maybe we need to think about how we're changing students' motivation, or how we're changing their attitudes towards science. Are they more interested in maybe pursuing a career in science engineering? If outreach is actually linked to what they're learning in the classroom, and again, partnering with the teachers is the key here, evidence is showing that you can boost students' motivation to learn because that relevance is there. Some research that's coming out of our own department with first-generation college students is actually showing that some pre-college programs have very long-lasting effects in terms of students' confidence in their choice of major. So these first-generation students were interviewed and asked, what resources helped you to be successful as a college student in science or engineering? And some of them identified pre-college programs, but specifically they said it helped them feel more confident that they were where they belonged. Though someone somewhere along the way told them in one of those programs, this is something you can do. And they believed that. And in spite of challenges and roadblocks that were in their way, they persisted and they succeeded. That's really powerful stuff. And another thing that can be sort of a non-cognitive outcome of outreach is role models. There are very few role models, especially for engineers in the mass media. But outreach gives us an opportunity to give them a better perspective of who we really are and what we really do. Right now, these are the kinds of role models that students see. And as much of a Big Bang Theory fan as I am, I don't know any cool inner city kid that really wants to look like Sheldon, right? So we want to make this real for them. We are real people, and it's attainable for them. They can achieve something like this too. So going back to that logic model template, looking at what we invest, what we do, who we are reaching, and what we're likely to be able to achieve with it, I want to try to do an activity. I thought about an interpretive dance, but this really probably not going to help me reach my objectives. So I'd like you to you can take out a pen and paper if you want, or maybe just think about it. Identify your target audience. Obviously, we're all here, we're at least interested in outreach. Think about an outreach program that you want to do. I'm going to give you a minute to do this. Identify your target audience and at least one outcome of your outreach activity. Okay, activity time is over. No more interpretive dancing. Okay. So thinking about those outcomes, what can they do for us? They can actually help identify those specific indicators and objectives that you need to identify that will show evidence that your outcomes are being met and that your outreach activity is being successful. So an example of an outcome might be that your students will have a more realistic view of the nature of science. This is a big issue, kind of a hot topic in science education right now, that our kids think that science is just knowledge that they learn from a book. They don't believe that they can actually create knowledge or that science is something that they can do. They think experts out there do it, that they can't actually do it. So what if we could change their minds about that? What if we could actually engage them in some kind of activity that will show them that they can produce information and knowledge that will contribute to science? So an indicator would be that maybe on a survey, they indicate what their perceptions are about the nature of science. And a specific measurable objective would be that a majority of the participants in your outreach program will report more realistic views about the nature of science before and after. After participating, there's going to be an increase in how realistic their view is. Another objective, an outcome might be talking about confidence. I mentioned that as some evidence that we're seeing in our research with respect to that. So maybe participants are going to tell you on a survey what their major is, what their intended major is, and their level of confidence in that choice. And an objective would be that they report feeling more confident about their choice. And that doesn't necessarily mean they're all going to be scientists or engineers. Maybe they're choosing not to be after participating in your outreach project. Like, this is not for me, and that's a good thing. You don't want them coming into your classroom confused. You want them to come to this decision to major in whatever their choice is from an informed perspective. And then if you're developing online resources, maybe you want your participants to go to that as a resource. So you can use web analytics as an indicator and have some kind of objective of how many people you want to have using your online resources. So that's how you can link outcomes to specific measurable objectives. So when you're writing objectives, objectives are basically, you start with the end in mind. You want statements of what your students should be able to do after participating in your outreach. They should be specific and measurable, and that way you can actually use them to produce data. And they can, like I mentioned before, they can be both cognitive and non-cognitive. You can have learning objectives like increases in skills or knowledge or topics that they might learn that they could use in school. And then non-cognitive outcomes or objectives might have to do with education or career goals that students have, or how confident they are in choosing those goals. So what do they do for us? They can guide basically every aspect of your outreach activity. They define where you intend to go and increase the likelihood that your participants are actually going to get there. They can guide your planning, delivering, and evaluating your activity. Even your participants, if you share your objectives with them, it helps them focus, it helps them know what's coming. And finally, as a guide for teachers, if your students are participating in an outreach program, you can partner with their teachers, and their teachers know what they're going to be coming in with, and they can design some classroom activities as follow-up and to build on, reinforce that activity. So, in the sake of time, I'm not actually going to spend a lot of time on this, but I think anyone who's taught has probably heard about Bloom's taxonomy. It's just a way of organizing verbs, basically, that help us write learning objectives, or objectives that have to do with learning. So simple things like remembering, memorizing stuff is pretty easy to assess. But things that are farther up that scale of complexity, where you're asking students maybe to evaluate things or create something, these are the kind of words that you would use to describe objectives within those categories. So I've got a link to this, and just again, for the sake of time, I just wanted to mention that as one way to write objectives, is using those specific measurable words. So kind of looking back to that map between outcomes and indicators, interpretive dance time, take your objective that you've identified, take your outcome that you've identified and write at least one specific measurable objective that you could achieve with the outreach activity that you have in mind. Oh, okay, we're just discussing Casper's outreach program. Anyway, okay, so you've got your target audience, you've got your outcomes, your intended outcomes, you've got your objectives as a way to measure that outcome, and now comes the hard part, actually assessing something. You actually want to see if those objectives are being met. So again, looking back at that logic model, you've got all those pieces in place. Now it's time to create that plan. So where do you find assessment tools? So those of us who teach know how to assess learning. We've written learning objectives, and maybe you've used Bloom's taxonomy. But what about those non-cognitive aspects? What about things like motivation or attitudes? There's a lot of instruments out there, and I would say to start with, try to find something that is already validated and that's already established for the age group that you're working with. And there are several resources, and I've listed them here. This field-tested learning assessment guide. This is a website, and maybe we'll go to it if we have time. NC State has a great website, their MISO website, looking at the impact of STEM outreach. They don't have instruments actually posted on that website, but you can email them and ask them for the instruments. They also have another, their physics education research group has a group of instruments posted on their website. University of Maryland has concept inventories. This kind of goes more to the cognitive aspect, our students understanding concepts better. And then Florida State has a really good collection of tools that they use to assess their research experience for teachers program. And they're not all just focused on teachers. A lot of them are focused on pre-college students and assessing some of the impacts of their programs on pre-college students. So some of those might be really useful as well. An example of one of the ones that I found on the Florida State site, and I actually used this one, is that Views of the Nature of Science, VNOS. And you might see this reported in the literature if you start looking at research on outreach programs. So this, again, is looking at how we're changing students' mind about what science is and how people do science. So this is an example of a few questions from the survey. What is science? What is an experiment? Does the development of scientific knowledge require experiments? And it goes on to ask questions about where does knowledge come from and that kind of thing. There's another one called Nature of Scientific Inquiry, or NOSI. So there are several different versions of these surveys out there. Again, I'd suggest not developing your own, because if you want to publish this, it needs to be done with a validated instrument, very much like if you're doing biomaterials research. You wouldn't just, poke a cell and say, yeah, that's healthy. You need to do some assays, and you need to do, there needs to be some validated measures behind what you're doing. A quick note about human subjects research. If you do want to leverage your outreach activity to get funding or to publish what you're doing, you need data. And if you're collecting data from human subjects, it has to be approved by institutional review board prior to collecting it. If your subjects are under the age of 18, you'll need parental permission, which is another layer of complexity. But it is possible, and your teachers can help you with that. And you as an investigator need to complete training, and that's done, most universities have access to this collaborative, I can't remember what city it stands for, but it's some kind of collaborative training program. It's an online module. I wanted to show an example of an outreach activity in which the people who were doing it partnered with education researchers. And this was a study that was done about research experience and mentoring program. It's an NSF-funded program. It was held at 2 universities, which will remain unnamed, in the Southeast. And these biomaterials researchers collaborated with science education researchers to develop a survey, and they validated the survey related to science, engineering, and research identity. And they identified this as something that they wanted as an outcome of their activity. They wanted these undergrad researchers to develop identities as researchers, to really think of themselves as researchers and as scientists or engineers. So this is an example of some of the items that were on their survey that had to do with research. Similar questions were asked about their identity as scientists and about their identity as engineers. And the outcome that they thought they'd have, again, was that they will foster the development of research identity for both science and engineering students, and they were able to produce evidence of positive outcomes of this program. This is hard data that they can now put in a report to the NSF showing really strong effects and really positive effects of their program. And as graduate students who are mentoring these undergrads, they now have a couple of publications based on that data. So that evidence was really strong, and some of the evidence was really interesting. They showed that science students didn't necessarily identify as engineers, but they did develop strong researcher identities. And engineering students identified both as scientists and engineers, but their research identities weren't as strong as those for science students. And I may have that really wrong. 2 of the authors are sitting in the audience, so I would recommend talking to Erin McCabe or Jordan Gilmore or Karen Berg, who are authors on this paper. And it's being presented at the American Society for Engineering Education in June. So just to kind of wrap up, a tip from the trenches is before you start your outreach activity, partner with somebody who knows education research. Partner with a teacher who can reinforce what you're doing in the classroom with these students. Talk to somebody who's an evaluation expert. There's actually an association out there called the American Evaluation Association. I had no idea this existed when I started throwing spaghetti at the wall. And you can partner with an education researcher. And there are these centers and departments cropping up all over the place. The University of Washington has the Center for Engineering Learning and Teaching. The physics education research community is a very active group, and they have this great online guide for doing evidence-based resources for doing all kinds of educational activities. And then, you know, shameless plug, there are departments like ours. We have a PhD program in engineering and science education. Our graduate students are developing tools and ways to assess different educational activities. There are programs like this at Virginia Tech and Purdue. Ohio State, I think, has a PhD program. They're cropping up all over the place. It's kind of going viral. I think people are starting to understand that showing pictures of smiling students isn't enough to show that your program is working. You really need to have evidence, and you need to be intentional about collecting it. So I'd like to finish with this thought from the humble genius, Albert Einstein. Everybody is a genius, but if you judge a fish by its ability to climb a tree, it will live its whole life believing that it is stupid. So I think our education system needs help. I think that we are in a great position to help it. I think a lot of our students are just bored by science because they see it as something that's static, that is only measured by how well they can fill in bubbles on a Scantron test. They don't see the excitement of what's going on in the biomaterials field. We need to show them that they do have the right stuff and provide evidence that they actually have it. So thank you for your attention.